Fibonacci sequence. And Tom, do you know the Fibonacci sequence?
Yes.
Let's just explain this really quick. So it's called the Fibonacci sequence. And basically you add the sum of the two previous numbers. And mathematically what that does is it gives you this pattern. And this pattern is seen throughout nature, in the subatomic particle to the galactic. So let's go to the next slide.
You got to answer a question though. How do a bunch of numbers like that turn into a diagram like that? Who decided to get the curve?
Well, you just graph it, right?
On what plane or what? I mean, help me out here.
Taking it as an area of 1, an area of 2, an area of 3, and so the spiral is taking up more area, and it's self-similar. It's moving around.
Does the math work out in that? Is that the real?
Yes, absolutely.
Oh my God, yes, it does. Let's go to the next slide. We'll show you how it works out.
Maggie, do you know that?
No, I'm fascinated though.
I didn't
You've
know.
not heard about the Fibonacci series?
Okay, so this is a little bit more of just the number. It's called the golden ratio because again, it's golden, baby, and you'll see why.
Or the golden mean is another term.
Yes, right. An ocean wave, a snail, a seahorse. A seahorse. I'm not sure what the seahorse has to do with. Maybe the tail looks a little curvy there.
The tail of the seahorse. Also,
Yeah.
male seahorses carry the babies around. Just a fun fact.
But even the horns of a goat or whatever that is, a bull, ram.
That's a ram. Thank you. From an Aries to an Aries.
Right. I'm an Aries.
So just so I'm curious about this. So just so I understand it, as your announcer, that you're talking the volume of these spaces correspond with the Fibonacci numbers, which correspond to the volume of these spaces.
Yes.
Huh.
Yes. So Mark, do you remember your calculus where there was a concept called an asymptote?
Yes.
Yeah.
It comes to the line, but it never touches.
Never quite touches.
So Fibonacci series creates an asymptote. That 0.618, the ratio. As you keep dividing the numbers as you move up, it gets closer and closer, but never crosses.
Does it continue to spiral? Does it always spiral?
Yeah.
Here's some examples of it here in everyday life and human figure form and art and nature.
Coming back to Dan Brown's movie with Tom Hanks.
All right, let's go to the next slide.
Apollo 13.
So weather. It's a nice hurricane or
not if you live in Florida. It's not nice.
And the next one, of course. There we go. There's a galactic one for you.
Okay.
So see, from the seashell to the galactic galaxy.
The golden ratio.
The golden ratio stays the same. It's pretty cool.
Who is Fibonacci? Or are we not going to talk about that, or did we already cover that?
We have not covered that. Tom, who's Fibonacci? Go.
Fibonacci was the guy who figured it out first.
Well,
he's an Italian.
Thank you. I kind of put that together.
He drank Dom Perignon and drove a Ferrari, as far as I know. Okay, next one.
Okay. Was he Italian? He sounds Italian.
He was Italian.
I think
he
was
lived in Pisa, Italy, and about in the year 1170.
Wow, that's.
They made Ferraris in 1170.
How does this relate to? Isn't there something about in Leonardo da Vinci's like the man that isn't there's like another, is the golden ratio part of that, or that's something different? Do you know what I'm talking about?
Well, yeah, but I think the point is that the human form holds true with the Fibonacci sequence.
Okay.
Yeah. So yeah, the golden mean was recognized back in ancient Greece, right? So if you look at the art and the architecture of like the Parthenon and the old Greek bodies, they were built in that golden mean. this ratio, this box here in the galaxy, those architectures use that. And human faces that follow the golden mean are more pleasant. So as Joe was saying, it's kind of just built into our DNA that we like it. If a face or a building, piece of art follows it, like the Mona Lisa,
Yeah.
we like it.
Yeah.
That's fascinating.